we are going to talk about subtractions now as we use them in Vedic math. This is the series, video number 2 in the series. I'm Sarwan Agrawal. I'm a certified VM teacher. So in this section we are going to discuss subtraction using the sutras in Vedic math, and I'm Sarwan Agrawal. I'm a certified VM. Let's go over some historical background. Veda means knowledge. Bharti Krishna Tirtha ji reconstructed Vedic system of mathematics in 1911 through 1918. Bharti Krishna wrote one introductory volume in 1958. This book was published in 1965. Shri Bharti Krishna Tirtha ji lived from 1884 through 1960. This is one of his. Let's go over outline. We are going to discuss this subtractions in 4 different sections. Subtraction using sutras, the first section. Subtraction as a game, second section. Subtraction using zones, third section. Subtraction using negative numbers, fourth section. We are now on the first section using sutras. All from 9 and the last from 10 is the main sutra used in subtraction. All from 9 and the last from 10 is the tens complement, and in my opinion the sutra is a lot easier to apply than tens complement is. Alright, let's see what do we mean by all from 9 and the last from 10. Let's consider this number 876. All from 9 means 8 from 9 is 1. So 7 from 9 is 2. 6, that's last one. 6 from 10 is 4. So 8 from 9 is 1, 7 from 9 is 2, and 6, last one, from 10 is 4. Another example here, we're going to do all from 9 and last from 10, 54. For 5, 5 from 9 is 4. Now for this last digit, 4 from 10 is 6. Another example here, 9, only one digit, so it's all from 9, last from 10. This is last digit, so 9 from 10 is. We're going to continue with sutra here, and let's make some observations here. Where can I use the sutra? We can use the sutra in subtraction, and we will use that in subtraction. How much is 876 plus 124? See, 124 is all from 9 and last from 10 of 876. If we add the two together, see what happens. That's 1000. 1 followed by zeros. Number of zeros is equal to number of digits in the first number or number of digits in the second number. Let's look at the next example here, where we say all from 9 and last from 10 of 54 is 46. If we add 54 and 46, what do we get? We get 100, which is 1 followed by 2 zeros. 2 zeros are number of digits in these two digits. Either number 54 has 2 digits and 46 has 2 digits. Alright, now last was all from 9 and last from 10 of 9 was 1. 9 plus 1 is 10. 10 is same pattern, 1 followed by zeros. So number of zeros here is equal to number of digits in the number. From the previous slide, we noticed 876 plus 124 is 1000. That means that 1000 minus 876 must be 124. So if you subtract 876 from both sides. Right side become 1000 minus 876 and left become 124. If you rewrite this problem here as two lines, 1000 minus 874, answer is it's 4 in the units column here, 0 minus 6, which is 6 from 10. 2 is in the tens column, which is 9 minus 7. That means 7 is from 9. The 1 is in hundreds column, which is 9 minus 8 is a 1. That means 8 from 9. And 0 is in the thousands column. So in thousands column, it must be 1 minus 1, which is 1 less than before. So in the 3 column, there were 3 zeros in the first row and non-zero in the second row. We had all from 9 and last from 10. In the thousand place, where we had a 1 in the first line and a 0 in the second line, we say 1 less than before. 1 minus 1 is 0. So answer was 0, 1, 2, 4. In the answer, we remove the 0 on the left. So that's 0, 1, 2, 4. That's this 0, 1, 2, 4 is same thing as 124. The 0 on the left doesn't mean much. So neither borrower nor lender B. In VM, we do neither. And what we do instead, we let the sutras do that for us. The sutras we have is all from 9 and last from 10. And also we also. Okay, let's go just look at this problem here is 1000 minus 589, which is of the same type we just discussed. First line it has a 1 followed by zeros, and second line have non-zero digits. Number of digits in second line is equal to number of zeros in the first line. Okay. We subtract using 1 less than before in the thousands place here of the non-zero digit in first line. So in the thousandth place of the answer we have a 0. Okay. All from 9 and last from 10 of the second line. So 589 we apply all from 9 and last from 10 to get a 4, 1 and a 1. Okay. Now we're going to discuss one example here, which is 10,000 minus 5832. Same pattern we had before, 1 followed by zeros, non-zero digit followed by zeros, and subtracted term has 4 digits and which is equal to number of zeros in the first row. In 10,000 place we apply 1 less than before. That would be 1 minus 1 and which is equal to 0. All right. In thousandth place 0 minus 5 we are going to apply from 9, all from 9 and last from 10. So 5 from 9 is a 4. So next digit of the answer is in thousandth places. In hundredth place we have 0 minus 8 and we are going to apply from 9 again. 9 minus 8 is 1. 8 from 9 is 1. So next digit of the answer is 1 here. We would get a 1 in 100. Now we have a 0 minus 3 here in tens place and we would apply from 9 again. Apply, so that's 3 from 9 is 6. 9 minus 3 is 6. In tens place we got a 6. Now we're going to, we need to work on the units place. We apply from 10. 2 from 10 is 8. 10 minus 2 is 8. So we have solved all the answer digits here. 0, 4, 1, 6, 8. The answer to 10,000 minus 5832 is 4168. We just ignored this 0 on the left of the answer. So what we did, we applied this sutra, all from 9 and last from 10 to the digits in the second row. Let's look up another example here, which is 50,000 minus 7392. It's the same format. A non-zero digit followed by zeros. Okay. In the leftmost column where we have 5, in the first line apply 1 less than before to get 4. So in the 10,000th place we would get in 4. We got a 4 in the leftmost place here, which 10,000 place, and we have a 7392 being subtracted from 50,000, and we just applied 1 less than before to the digit in leftmost column. For the rest of these we have to apply all from 9 and last from 10. So in the other column we apply all from 9 and last from 10 to 7392. So where 7 is, we get from 9 is a 2. For 3 is from 3 from 9 is 6. When 9 is, 9 from 9 is 0, and last one 2. 2 from 10 is 8. So all from 9 and last from 10 of 7392 is 2608. So 260. So we have got an answer 42608. We have solved for all 5 digits of the answer. So the answer to this problem is 50,000 minus 7392 is 42608. 42608. Let's consider some exercises. 100 minus 73, 1000 minus 276, 10,000 minus 8910, 50,000 minus 6934, 30,000 minus 2367, 5,000 minus 853, 7,000 minus 457. You can do these and some other similar examples. Let's look at this problem of 18 buys a game for $73.54 and hands the cashier a $100 bill. How much change does she get back from the cashier? So this is a change problem, and we would apply the sutra we just discussed to solve this problem. So we need to solve $100 minus. Okay, so that is similar to 10,000 minus 7354. Remove the dollar sign and remove the dots, decimal points. So we get it similar to, we are left with 10,000 minus 7354. After we apply sutras, which becomes 2646, 1 becomes 0, 7 becomes 2, 7 from 9, 3 becomes 6, 3 from 9, 5 becomes 4, 5 from 9, 4 becomes 6, that last one, 4 from 10. So answer to this problem is $100 minus $73.54 is 2646. So we have used these sutras. Okay, you can use the sutras to do $10 minus $5.34, $1 minus 58 cents, $100 minus $29.35, $20 minus $12.79, $50 minus $35.78. Yes, you can use them in pound and cents also, and also rupees. Now we would discuss a general problem which does not exactly fit into this pattern we just discussed. So, but I don't have a problem that fits the pattern discussed before. Let's see what we do here. So let's consider this problem here. 75489 minus 48934. First row does not consist of a non-zero digit followed by all the zeros. Okay, but instead it has a general form 75489. Let's see what we can do here. We will split that into two problems. Which ones? One of that subtraction matching the previous pattern. So we know how to solve a problem, subtraction problem of the type we just discussed. So we would split that into a problem of that type and another of addition. So we would, instead of one problem of subtraction, we would do two. So we were looking at this problem here, 75489 minus 48934. We had decided to split that into two problems. So first thing we do is by addition and by subtraction, we change the problem to 75489 minus 48934 as before, plus 5489 minus 5489. So add 5489 and subtract 5489. The number 5489 we use here came from the last four digits of the first line, 75489. So we have subtracted and added 5489. We are trying to convert 75489 to 70,000. That means we would regroup minus 5489 with the 75489. So this our regrouping is 5489 we still have at the end. This minus 48934 is still here, and this minus 5489 we regrouped with the 75489 here. So that's a 70,000 minus 75489 minus 5489 is 70,000. This minus 48934 and plus 5489. This one inside the parentheses we can solve using the sutras we have been doing. In the leftmost column we have 1 less than before, which is 7 minus 1 minus 4, which is 2. In the rest of the column is all from 9 and last from 10. 8 from 9 is a 1, 9 from 9 is 0, 3 from 9 is a 6, and 4 from 10 is a 6, 21066 plus 5489. So we would add these two numbers together. Basically we have converted this problem to its equivalent problem, which is that which this problem is equivalent, which is equivalent to this problem, and which is we solved first subtraction problem, and then after that this term plus that term is equivalent to the original problem, and you can add them together and to get a 26555 as answer. So wasn't that divide and conquer? So we kind of divide and conquer. We split in the one problem into two simpler problems. One of them we applied the sutras right. There are some exercises you could do. First one example I use is 28652 minus 2171316. Next example I use is 622060 minus 467393. Next is 849788 minus 218112, and some more. Okay, now let's get back to our next section here. Now we are going to do subtraction as a game. So let's see how do we call subtraction as a game. Okay, we would develop this game here, subtraction game. In a game there are two teams. In subtraction there are two lines. First line is the home team. And second line in subtraction is visiting team. So when you say first line minus second line, first line is subtracted from number and second line has a subtracted number. So subtracted from number, our first line is the home team, and second line is subtracted number, which is second line is a visiting team. And the goal of the game is to meet or beat the challenge of the visiting team. So we have to at least get tied. Home team has to win or at least have to be tied. We would need some definitions for the game. First definition we are going to talk about is surplus column. In this game of subtractions, there are two teams and each team has a player at different positions. And these positions are the columns. So we would look at the matchup at various columns, and surplus column would be if solving the subtraction game in a column or at a position lands to the right of a 0 on a number line, that column is surplus. Let's look at example here. If a column had a 5 minus 3, that would mean we would walk 5 steps to the right and walk back 3 steps to land at 2, which is to the right of 0. 0 is here and 2 is to the right, and a column with a 5 minus 3 would be a surplus column. Let's look at next type. Next type of column is sufficient column here. Let's see what that is. A sufficient column is if solving the subtraction game in a column, which is column is a position in our game, land at a 0 on a number line, that column is sufficient. Let's look at example. If a column has a 4 minus 4, then 4 in the first line and 4 in the second line, that would mean that we would walk 4 steps to the right from 0 to land at a 4, then walk back 4 steps, land back at 0. So solution of this subtraction game in this column land me back at 0, and that column is a sufficient column. A column with 4 minus 4 is a sufficient. Alright, let's go look at it. A deficient column here. A deficient column is if solving the subtraction game in a column lands to the left of 0 on a number line, that column is deficient. Let's get an example here. Example would be if a column had a 5 minus 7, 5 in the first row and 7 in the second line, that would mean we would need to walk 5 steps to the right from 0 to get to 5 here. Then we would walk back 7 steps to the left to land at minus 2, which is at the left of a 0. A column with 5 minus 7, 5 in the first row and 7 in the second row would be a deficient column. Of the game, first rule is always subtract a smaller number from a larger number. So first line has to be larger and second line has to be smaller. That basically means we are going to stack the game in favor of the home team. So home team has to win. Rule number 2. A column with a tough challenge can count on help from higher placed column on the left. Columns on left are higher placed and columns on the right are lower placed. And in a family situation, columns on left are like elder siblings, and elder siblings look out for younger siblings in need of help. So if a column needs help, it can count on help. This help is mandatory and there are no exceptions. There are no exceptions, help has to come. Rule number 2. A column may both receive help of 10 and give help of 1 unit. Amount of help gotten is always 10 and amount of help given is 1. The column on left gives a help of 1 unit of its value, and which is worth 10 units of value of the next column on the right. in this situation in 2a, that would leave a net help of 9 for that column. If a column gives a help of 1 unit and it gets help of 10 units, is left with a net help of 9. Alright, let's look at an example. Example is 587 minus 345. Let's look at a matchup on units column. 7 minus 5. Our player is 7. It can easily handle the challenge of 5. And 7 minus 5 is 2. In this case, the column is a sufficient column, and answer is a 2. Let's look at tens column. Matchup in this position is 8 is our player and 4 is the challenging player, and our player 8 is in a very good situation to handle 4 without any help. So answer here is 8 minus 4 equals 4, and it's a surplus column. Let's look at the hundreds column. Hundreds column is surplus 2, 5 minus 3. 5 is in very good shape to handle 3, and so answer is 5 minus 3 equals 2, and the column is surplus. Wasn't that easy? I do not rush to apply sutras. Sutras are not always applicable. I have seen students trying to apply sutras even when sutras were not called for. Here is a cartoon of trying to show that a unit of help given from left becomes 10, and it goes through 10 to 1 conversion, and show helper loses 1 unit of its value and receiver gains 10 units of its value. When I learned subtraction to start with in second grade or so, and we were borrowing from left, we stick that borrowed 1 to the left of the next digit on the right. And nobody told me that we stick to the left because it was worth 10. And this cartoon reinforces that idea that when you're borrowing from left, the column is higher placed, and its 1 is equal of value equal to 10 units of the value of the next right column. Let's look at another example here. Example this time is 593 minus 386. Now we are going to look at a matchup at units place. Our player is 3, and matching a competing player is 6. So 3 is in tough shape here. It breaks the rule number 1. Our rule number 1 say subtract a smaller number from the larger number. At least in units place, that rule doesn't hold. So what do we do? Would we give up the game? Hey, no way, we won't give up the game. Our goal is to win the game. So what do? We continue and use rule number 2. What does rule number 2 say? We'll use teamwork. We would use teamwork to continue. So we will win this game using teamwork. And rule number 2. Let's see what rule number 2. So in rule number 2 say we would get a help of 10 from left, which would you can count on a help. Help is of 10 units. So 3 minus 6 after we got a help is 3 minus 6 plus 10. How would we regroup this thing? Would you do 3 minus 6? We don't know how to do 3 minus 6 easily. Okay. Would you regroup like 10 plus 3 minus 6? That's the one that taught me in second grade. Stick the one borrowed from left column to the left of 3, become 13. Okay? That makes 13 minus 6. And conventional math folks do that all times, and that require subtraction from a larger number 13. And in Vedic math, we would rather not subtract from 13. So what do we do instead? In our math, we regroup as 3 plus 10 minus 6. We apply the help we just got to the challenge. We throw the help we just got to meet the challenge here. So that is 10 minus 6. We regroup as we hold on to our player 3. We got a help of 10 from left. We throw that help to the 6 to overpower 6. So we subject the challenge to the help we just got. So we apply the help to the challenge. Okay, so 3 plus 10 minus 6. 10 minus 6 is a 4. 4 plus 3 is 7, and that is equal to 7. So that tells me I get 7 of answer in a units place. And what we just did, we apply from 10 to the digit in second row. What we did is 6 from 10. 10 minus 6. 6 from 10 plus 3 equals. So now we have a 7 in the units place. Let's look at the tens place. In tens place we have a surplus, 9 minus 8. But this column has given a help, so it is 1 less than before. Instead 9 minus 8, we have 8 minus 8. So we apply 1 less than before to the digit in first row. We apply 1 less than to our own player. Tens column has given a help of 1 to the units column. So situation here is 9 minus 1 minus 8, which is 9 minus 1 is 8, 8 minus 8 is 0. So answer in a tens column is 0. Okay. Now let's continue with hundreds column. Hundreds column is 5 minus 3. 5 minus 3 is a surplus column, and our player 5 can handle the competing player 3 easily. So we say 5 minus 3, no obligation to the right. And so now we have in a hundreds place we have a 2, and we have all 3 digits of the answer. The answer to the problem 593 minus 386 is 207. Okay, let's look at another example, please. Example this time is 6372 minus 2473. We would do same thing again, like do analysis at one column at a time, starting from the units place. In units place we have 2 minus 3, which is a deficient column. At 2, our player is outnumbered by the opposing team's player in the same place, and we would need help. And what do we do? Rule number 2, and teamwork to continue. So after the help, matchup is 2 minus 3 plus 10. And our strategy is to apply the help against the challenge. Our strategy is to apply the help against the challenge. So we would regroup it like that. 2, we'll hold on to our player 2. We will hold on to our player 2 here. And the help we got 10 from left, we would apply against the challenge. So 10 minus 3. 10 minus 3 is 7. 10 minus 3 is 7 plus 2 is 9. 2, that's 9 in the units place. And what we just did, apply from 10 to the digit in second row. What's digit in second row? Is challenge. So what we did, we applied from 10 to the challenge in that column. From 10 to the. Alright, we have a 9 as answer in the units place. Let's continue with the tens place. In tens column, it's 7 here, but has given help to the right, a younger sibling. So this 7 is in fact only worth 6 now. A situation is challenging. Our player has a 6, the other player is 7. So our player is in tough situation. What do we do? Rule number 2 and continue. After the help, we have a 7 minus 1 for the help given, minus 7 for the challenge, and plus 10. And our strategy is to apply the help against the challenge. Net help here is 10 received and 1 given. So we will regroup like this. First we'll hold on to our 7 like here. Then get all the help, 10 minus 1, which is 9. Apply that against the challenge. So 10 minus 1 minus 7. So simplify further is 7 plus 10 minus 1 is a 9. 9 minus 7 is a 2. 7 plus 2 is a 9. So what we just did? Applied from 9 to the digit in second row. What's the digit in second row? That's challenge. So we applied from 9 to the challenging digit. We applied from 9 to the challenge. Let's continue further. Now we are a hundreds column. Is 3 minus 4, but this 3 has given help to the right of 1 already, so this is only 2 now. So 2 minus 4 is a tough challenge. Our player is worth 2 and competing player is 4, so we need a help. We apply rule number 2, and that's a 3 minus 1, 1 help given, plus, minus 4 was challenge plus 10. Our strategy is to apply the help to the challenge. So we will regroup that like this. Our player 3, we hold on to that. This help received minus 1. Net help for 10 minus 1. We apply that against 4, the challenge. So let's simplify a little further. 3 plus 10 minus 1 in the parentheses is 9. 9 minus 4, which is 9 minus 4 is 5. 3 plus 5 is 8. So what we did? We applied from 9 to the digit in second line. And what is that? Challenge. We applied from 9 to the challenge. Okay, now answer in this hundreds column is 8, and we got one more column to go. So we have 899 already, and we have 6 minus 2 in the thousand place, which is surplus, but 6 has already given help 1 unit to the right. So this column has given, so situation is 6 minus 1 minus 2. 6 minus 1 is 5, minus 2 is a 3. So, and apply 1 less than before to the digit in first row. What digit in first row? Our own player. So 1 less than before we apply to our own player, and all from 9 and last from 10 we apply to the challenging players. So now I have 3 in the leftmost column, and answer we can rewrite restate that 6372 minus 2473 is 3899. Now you can do some problems. First problem is 77 minus 39, 348 minus 253, 5734 minus 3629, and some more. Okay, we would now start on third section, subtraction using zones. Okay, let's go make some observations. From previous work, we have noticed that in a challenge section of the problem, which is subtraction problem, we apply all from 9 and last from 10 to the digits in the second row. And second row is those are digits are players in a challenging team. These are, so we applied the all from 9 and last from 10 to the challenging team players in a section where our team players were challenged. Okay, in surplus column just left to challenge section, we apply 1 less than before to the digit in first row, which is my home team player. Okay. And in all other columns, it's a straightforward subtraction and no sutras used, no sutras applicable. Now let's look at what dreaded zone is. We are going to define 3 zones now. Dreaded zone is the zone starts with a deficient column on the right. So as soon as we find a deficient column on the right, a dreaded zone starts. That's where we would have issue in subtracting. At least the home team player is challenged and would need some help, and grows through deficient and sufficient columns on left. So it's just not the one column that's in dreaded zone, it's the all other columns to the left which are deficient and sufficient. And this growth stops with surplus column. As soon as we see a surplus column, this growth stops. Note that the surplus column is not part of dreaded zone and all other columns are. So deficient column on the right, and just left to it all the deficient and sufficient columns are in the dreaded zone, and surplus column to the left of the dreaded zone is not in dreaded zone. Note, for every dreaded zone there is one surplus column to stop the growth, and this is guaranteed by rule number 1, which says always subtract a smaller number from a larger number. Let's look at some example here. The example we are going to look at is 5, 3 minus 4, 5. In units column, we have 3 minus 5. Our player is 3. It's outnumbered by the visiting team players 5. So challenge is 5. We are 3. So it's in a deficient column, and dreaded zone starts here. This column is in a dreaded zone. Okay. And tens column, 5 minus 4, which is surplus column. This surplus column stops the growth of the dreaded zone. So dreaded zone does not grow anymore. Okay, so surplus column 5 minus 4 is not in this zone. So dreaded zone in this case consists of single column, which is the units column. Let's look up another example. Example, we are going to look up now 3 digits example. 653 minus 355. Units column is deficient. 3 minus 5. Our player is 3 and the challenging players is 5, and 5 outnumbers 3. So our player is challenged. So it's a deficient column and is in dreaded zone. Tens column is a sufficient column and not surplus. So the growth continues through this column, and this column is also in a dreaded zone. In hundreds column, 6 minus 3 is a surplus column and is not in dreaded zone. This column, surplus column, stops the growth of the dreaded zone to the right. In this case, we have dreaded zone consists of 2 columns, the units column and a tens column. Note, so this was a sufficient column, the tens column was, but it came in dreaded zone because the column on the right was deficient and was in dreaded zone. So right association of a deficient column dragged a sufficient column into dreaded zone. If it was out, if the right column was not deficient or not in dreaded zone, 5 minus 5 would have been a safe column. But because of the right association of a dreaded zone column, 5 minus 5 is in a dreaded zone. Okay. Now we are going to look at a payoff column. The surplus column which terminates the dreaded zone growth is a payoff columns. In the previous example of 653 minus 355, hundreds column is a payoff column. In new example here, 4687 minus 2688, let's look at what's going on. In units place, it says 7 minus 8, which is deficient and in dreaded zone. Tens column is 8 minus 8, which is sufficient and not surplus, so it's also in dreaded zone. Hundreds column is 6 minus 6, which is sufficient and not surplus, it's also in dreaded zone. Thousands column, 4 minus 2. 4 minus 2 is surplus and it terminates the growth of the dreaded zone to the right, and it is a payoff column. Let's look up now safe zone. In subtraction, we have dreaded zone we discussed already, and some are payoff columns, and anything left over, rest are all safe zone. They are all in safe zone, they are all safe columns. Okay. So in consider 25478 minus 13397. Units place 8 minus 7 surplus, nothing to the right to worry about, no right association, so it's a surplus column, it's a safe. A tens column, 7 minus 9, it's a deficient column, so it's in a dreaded zone. Let's go move forward to the left. 4 minus 3 on hundreds column, that's a surplus column, and it terminates the growth of the dreaded zone that started in the tens column. So 4 minus 3 hundreds column is a payoff column. Thousands column, 5 minus 3 surplus column and no obligation to the right, so it's a safe zone. 10,000 column, 2 minus 1 surplus column and no obligation to the right, it's also safe. Units column is in safe zone, just like tens column is in dreaded zone. Hundreds column is payoff column, we just discussed. And thousands and 10,000, 25 minus 13 are in safe zone. Now we will look through the rules of subtractions for these zones. In dreaded zone, apply all from 9 and last from 10 to the digits in the second row, which is a visiting team players. Digits are players. In the second row is a visiting team. So it's a dreaded zone where subtraction rules are apply all from 9 and last from 10 to the digits in the second row, which are the visiting team players. In payoff column, apply 1 less than before to the digit in first row. That's our 2 home team player. So in home team player in the payoff column, we apply 1 less than before. In safe zone, straightforward subtraction. Digit in first row minus digit in second row. No sutras applied, no sutras applicable. Note, after identifying the zones, we can subtract left to right as easily as we can from right to left. Okay. Now we would do an example of subtraction by zones. Example we are considering is a 7-digit subtraction 9092588 minus 3094841. Okay. First we would identify the types of columns. So let's look up the columns here. Units column is units and tens column are safe. 8 minus 1 is surplus, 8 minus 4 is surplus, nothing to write to worry about. So these are safe columns. So we identify 2 safe columns, and let's continue identification of the other columns. Hundreds column 5 minus 8, which is a our player is worth 5 and the challenging player is 8, so it's a deficient column. We need help. And let's go look at next here. Thousands column 2 minus 4, it's still deficient. So dreaded zone starts here, and thousands column is in the dreaded zone. Now let's look at 10,000s column. 9 minus 9 is sufficient column, not surplus. Dreaded zone continues. Started at hundreds column, continues through 1,000 and 10,000. Look at 100,000 column. 0 minus 0, sufficient column, not surplus. Dreaded zone continues. So 100,000, 10,000, 1,000 and hundreds columns are still in dreaded zone. Look at 1 million's column. 9 minus 3, which surplus, and dreaded zone grows no more. So only these 4 columns are in red zone. Hundreds, 1,000, 10,000 and 100,000 columns are in dreaded zone. Let's go continue. Okay, we identified 4 columns of dreaded zone and 2 of safe zone. Let's continue with the millions place here, which we know it is surplus, but let's continue. In leftmost millions column is surplus column. 9 minus 3 is surplus, and it's to the left of the dreaded zone, so this would be a payoff column. Now we have identified all the columns for the type. Let's start subtraction now. In the payoff column, we say 1 less than before to our own team player, 9 minus 1, minus 3 for the competing player's position. So 8 minus 3 is 5. So in leftmost position, answer digit is 5. We have gotten 1 digit of the answer. Let's continue further for the other digits of the answer. In the dreaded zone, which is 4 digits, 0, 9, 4, 8 in second row and 0, 9, 2, 5 in the first row. In dreaded zone, apply all from 9 and last from 10, 2, 0, 9, 4, 8, which are the these digits in the second row, which are the challenging team. So, and all from 9 and last from 10 of 0, 9, 4, 8 is 9, 0, 5, 2, which all from 9. 0 from 9 is a 9, 9 from 9 is a 0, 4 from 9 is a 5, and last digit 8. 8 from 10 is a 2. So in these 4 digits here, we got it 9052. Okay, what do we do now? Add 9052 we just obtained to the 4 digits in the first row in same positions here, corresponding 4 digits here. We're going to add 9052 plus 0925. We'll do left to right. There are going to be no carries, they're guaranteed here. 9 plus 0 is 9. 0 plus 9 is a 9. 5 plus 2 is a 7 here. Another 5 plus 2, 7. So last 4 digits of the answer are 9977. Let's continue. Okay, now let's see. In the safe zone, it's 88 minus 41. It's a safe, subtract straightforward. You can do 1 digit at a time or you can do both. 8 minus 4 is 4 in a tens place. 8 minus 1 is 7 in units place. So 47 is the answer in last 2 digits positions. Continue. So answer is so far 5997747, and we have computed answer for every digit's position in subtraction. So let's summarize this thing. So for the given problem, 9092 minus 588, which is that one, minus 3094841, which that one is 5997747, which is that. Okay. Example problems here. Try these. 329493 minus 242098. 413869 minus 343972. 851236 465261. All these problems are 6-digit problems, and if you're uncomfortable with 6 digits, would rather do 5 digits, just drop off a column on the right. Okay, and then some more. Okay, let's continue with the last section, which is subtraction using negative numbers. All right, in subtraction using negative numbers, let's go brush up the basics. We need a brief primer on negative numbers. Consider the number line. Number line 0 in the middle here, and to the right we have a positive number. If we go from 0 to the right, we go enter and counter numbers like 1, 2, 3, 4 positive numbers. And if we do go to the left from 0, we got a -1, -2, -3, -4. So positive numbers on the number line are to the right of 0, and negative numbers are on the left of 0. So when we travel to the right here, and when we travel to the left, it's a -1, -2, -3, and when we travel to the right, we have 1, 2, 3. Okay. Let's continue with the primer. For every positive number, say 3, there is a negative number, which is its reflection about 0 on number line. So reflection of a 3 about 0 on number line is -3. And if we say reflection of 0 on number line about 0 is -3. So that means if you go 0 step to the right from 0 and go back 0 step to the left, you're still at 0. So for 3, to get at 3, we start at 0, go 3 steps to the right, we obtain 3. For -3, we start at 0 and travel 3 units to the left to get it -3. And in a subtraction problem here, 5 minus 3 would be go from 0 positive interaction 5 and negative interaction 3, we are at 2. If we start at 0, go 3 steps to the right and 5 steps to the left, we are at -2. Okay, we can use -2 in a number. I mean, let's say there were number 2, 3, 4, and a 2. If we last 2, we want to say -2. I can't say 2, 3, 4, -2. Okay, that changes the meaning of the number. So we use a notation. We use a bar underscore to denote a negative numbers. In Vedic math books, the bar is used over the numbers, negative numbers, and my word processing programs make it very hard to use a bar over the numbers, so I use a underbar underscore. Okay, let's continue this primer here. Let's get some more examples here. So let's say 7 minus 2, which is minus 2. We go from 0, 7 steps to the right and 9 steps to the left on number line. We are at minus 2 and we will represent that as a underscore 2. 3 minus 6, go from 0, 3 steps to the right on number line and 6 to the left. We have minus 3. We, we represent that as a underscore 3. 2 minus 7 is minus 5 and we'll denote that as underscore 5 and some more examples. Let's consider example. Example is 48901,652 minus 37775,802. We are going to subtract this 8-digit number from another 8-digit number. So subtract from left to right. In this, using negative numbers, I have no borrows to worry about and I can do left to right, right to left, either way. Okay? So in leftmost column, which is 10 millions column, we have 4 minus 3, which is 1. 4 in home team player and a 3 is a visiting team players. Challenge is 3, 4 minus 3 is 1. In 1 million column, we have 8 in the home team and 7 in the visiting team. Challenge is 7 against 8, so we have a 8 minus 7, which is 1. In 100,000 column, we have 9 minus 7, and it's surplus column again, and 9 minus 7 is 2. Home team player has no problem handling the visiting team player in the same location. In 10,000 columns, we have a 0 minus 7. This is the deficient column, and it's 0 minus 7 is minus 7. We would denote that as underscore 7. Okay? Okay. So we have already computed the first 4 digits of the answer. First 4 digits started from left. Now let's go back to the thousands position here. In thousand place, we have 1 minus 5, which is minus 4, and we'll represent that as a underscore 4. In hundreds place, we have a 6 minus 8, which is minus 2, and that looks like this. Okay, and in tens place, we have 5 minus 0, which is 5. No underscore required, it's positive 5. In units place here, we have a 2 minus 2, 2 minus 0. Okay. No underscore required here either. Okay. All right, let's look at continue the example. We have solved for all 8 digits of the answer. The only issue is we have 3 negative digits here, 7, 4, 2, which is this is hundreds place and this is thousands and 10,000 place. So we resolve 742, which is negative 742. We combine a negative number with a larger positive number, and that larger positive number is 2 on the left, and which is a payoff column. So let's go see how let's take up the small portion of the problem, which is 2 on the left and 742 negative on the right. So it's a 2 within this small problem. We just extracted from here 2742. 2 is a 2000 a positive and 742 is a negative. 2000 minus 742. Now we can apply our familiar sutras. All from 9 less from 10 to 742 and 1 less than before to 2. 742 is challenging team and in the columns where home team was challenged. So we apply all from 9 and last from 10 to the challenging teams players in the challenged section. So that's 258 and 1 less than before to the home team player in the payoff column. Okay, so we have 1, 2, 4, 8, 5, 8 here instead of 2, negative 7, negative 4, negative 2. Let's go. So we just replaced 1, 2, 5, 8 here. Okay, and so our answer is we got all positive numbers in the answer. The answer to 48901,652 minus 37775,802 is 11,125,850. Some exercises now. Try these. 59096286 minus 46303502, 55499014 minus 37410489, and some more. I have 8-digit examples here, and if you are uncomfortable doing 8-digit subtraction, drop off a few columns on the right. So if you six digit is what you would rather do, then do 636441 minus 273943. Okay, there are three rules to remember. Apply all from 9 and last from 10 to the digits in second row, which is visiting team players of the challenge section. When our home team is challenged in some section, in that section we apply all from 9 and last from 10. We do that to the players of the visiting team in that section. Okay? And apply one less than before to the digit in first row, which is our home team player. To the home team player of the payoff column, we apply one less than before. In the rest, it says straightforward subtractions. And note, identify the challenged and payoff columns to apply sutras to, and a straightforward subtraction in the other safe columns. Okay, let's continue. All books use at least the main sutra, all from 9 and last from 10. The books do subtract 1 and may not recognize the helper sutra of 1 less than before, which I have recognized here. Okay, subtraction as a game and subtraction by zone is not in any of the texts I have seen. I have used subtraction by negative number in the way I understood from Kenneth Williams' class in the teacher's training class. Vandana Singhal and James T. Glover combined the two steps, subtract by negative numbers and resolve negative numbers in one step, and do not introduce negative numbers. Tirthaji does not have a chapter on negative numbers or on subtraction, but he has assumed that reader is familiar with the topics. Some references. Main reference I would say is Teacher's Manual, which is the one we used in our training. A Vedic Math for Schools by James T. Glover has subtraction problems. Vedic Math for All Ages by Vandana Singhal also has subtractions.